Hi, good morning all. Welcome back to our channel. So today we are going to solve the problem number 37. Here the given is find the value of this load resistor. We need to find this load resistor value of the given network in such a way that maximum power transfer will flow. So we need to find out two conditions. So first we need to find out VOC, and next we need to find out R Thevenin. R Thevenin is equal to RL, then maximum power transfer will occur. And we need to substitute the formula of maximum power. The formula for maximum power to be transferred from source to load is equal to VOC whole square divided by 4 into R Thevenin is the formula we require. Okay, already derivation is there in our channel. In the lecture 36 you can go through this derivation. Okay, now let's try to solve this problem. Okay, so the procedure is saying is first we need to find out VOC. How to find out VOC? This is a very simple question. So first remove the load resistor. As soon as you remove the load resistor, automatically those terminals or those ends will act as an VOC. Okay, so I'm removing the load resistor and I am redrawing the network for your clarity. So this load resistor is removed. So whenever you remove the load resistor, these two terminals will act as an VOC. This 4-volt source, 1 ohm, 2 ohm, 5 ohm, 1 ohm. Okay, so this node is VOC. Okay, so automatically this will create a one more new node. Let us try to label this node, this unknown node voltage as Vx, and one more resistor is there, some voltage source is there. This will create a one more node which is nothing but Vy. So now we are having two nodes, one is Vx, another one is Vy. Okay, now let's try to solve. So to find these voltages, let's try to apply nodal analysis. Okay, apply nodal analysis at node Vy. So at this node I'm going to perform this nodal analysis. So here you can see, here there's no currents are given, that's why I'm directly marking this current as some I1, this current as some I2. This has some I1, this has some I2, and this has some I3. Okay, so when you draw it, let's try to see here how the problem is moving. Okay, so now what are the entering currents? Nothing is entering. So applying nodal analysis is just applying KCL at node Vy. Okay, so here the things you have to listen very carefully the class. Why? Because no, this is like very interesting and with full focus only how to do it. Okay, so apply KCL at node Vy. So this is one branch, this is another branch, this is another branch. Three branches we are having. All the branch currents are leaving. There is no entering currents. Therefore, 0 is equal to I1 plus I2 plus I3. Therefore, 0 is equal to, how to write down is I1, we can write down the node voltage here is Vy. So current is leaving. So Vy, and here the current is leaving. The terminal is 4 minus 4 divided by R. R value is how much? What is the branch resistance here? 1, plus how to write down the current I2 which is flowing in this direction. So from here to here. So this nothing but I2 I can write down as Vy minus 0 divided by 2 plus. So how to write down this branch current? I3 current we have to write down. How to write down this current is Vy. So current is leaving, and this is positive terminal and negative terminal. But the leaving polarity minus Vy minus Vx divided by R. R value is 5. Okay, so this is the one procedure of solving. Now when you simplify this, take Vx and Vy as separate. Therefore we are going to get 4 is equal to minus 0.2 Vx and take Vy as a common term. When you take Vy as a common term, this is nothing but 1 plus 1 by 2 plus 1 by 5. So automatically you are going to get the equation as 4 is equal to minus 0.2 Vx plus Vy into, so 0.2, so 1 plus 0.2 plus 0.5, so overall this is 0.7 and this is 1.7. Okay. So this is the equation we are going to get. So similarly, I require the value of Vx here. Therefore, apply nodal analysis. Applying nodal analysis is indirectly applying Kirchhoff's current law at node Vx. See here, already the current in this branch is 0. Okay, we require the current in this branch where I am going to, already I3 is completed, I4 I am marking, and current in this branch I am marking as I5. Okay, so apply nodal analysis. Okay, so here there is no entering currents. Okay, so 0 is equal to, only two currents are there, so this is the first current. Okay, this current I am going to write down as I4, and next current is the current which is flowing downward direction. I'm writing this current as some I5. Therefore, 0 is equal to, how to write down this current flowing from Vx to Vy. Okay, so we have to write down it as Vx minus Vy divided by 5 ohms plus, how to write down I5, this is Vx minus 0 divided by 1. Okay, so now when we simplify it, then we are going to get separate Vx term and Vy term. It's nothing but Vx of 1.2 minus Vy of 0.2. So this will act as equation number 2 and this will act as equation number 1. Use your calculator and solve it, then we get the value of Vx is equal to 0.4 volts is the first one, and Vy we are going to get it as 2.4 volts. Okay, just use your calculator. Next, after finding Vx and Vy, actually what we require is, our interest is to find this one. Okay, so here we have Vx and followed with the node VOC, positive, negative, and this is, here I have a small battery, okay, with 6 volts. So I want to link all these 3 voltages. So in order to link all these 3 voltages, I'm going to apply voltages are there. I'm going to apply Kirchhoff's voltage law in the loop to link VOC and all. Okay, so I am assuming current is flowing like this. The leading polarity is plus Vx, and here the leading polarity is minus VOC, and here the leading polarity is plus 6 is equal to 0. So Vx plus 6 is equal to VOC. So now what is the value of Vx we have to find is 0.4 plus 6 is equal to VOC. Therefore, VOC is equal to 6.4 volts. So successfully we find the value of VOC. So VOC is equal to 6.4 whole square divided by 4 into RThevenin. We need to find this RThevenin value. Already the procedure of RThevenin is already disclosed. Let's try to solve it. So I'm copying the same network to make you the things better. So the next step is finding out R Thevenin. Okay. So how to find out RThevenin is very important. So you can see here we have got the network now. So we need to find out the value of RThevenin. So the formula of RThevenin, how to do it is, so initially remove the load resistor. Remove the load resistor and the voltage source is there. The magnitude of voltage source is 5 volts. You deactivate it. Deactivating an voltage source is indirectly making it as short circuit. And I have an battery here, and this battery also of 6 volts magnitude is there. Just deactivate it, automatically the voltage becomes 0. So now, and the procedure of finding RThevenin is remove the load resistor and find the resistance offered from the open circuited terminal. Okay, so I'm redrawing the network for your more clarity. So this source is short circuited, and here you have 1 ohm, and here you have 2 ohm. Okay, and here you have 5 ohm, and here you have 1 ohm. Okay, and this is of 6 volts. So this is short circuited, and this source also short circuited, and these are the remaining branch 1, 2, 5, 1. So we need to find out R Thevenin looking from the open circuited load terminal. When you look out here, you can see here the current starts flowing. Okay, so when you find it here, so here we are going to have two things, 1 and 2 are connected in parallel. Okay, so when you see here, current is dividing, these two are connected in parallel. Okay, so whenever these two are connected in parallel, then we are going to get only one branch. Okay, and here we are going to get the another branch like this. So when 1 and 2 are connected in parallel, then product of resistance divided by sum of resistance. Product is 2 by 3, and this is 5, and this is 1 ohm. Okay, so this is 2 by 3, and this is 5. Again you can see here the current is flowing like this. Again these two branches are again connected in series connection. So these two are connected in series. Okay, so when you perform it, 5 plus 1 by 3, then you are going to get a single resistor. So if you have any doubt, assume this as some node 0 and this as node 1. So this is node 1, this is node 0. So now 5 by 2, this value is 0.66, and this is 5. So therefore we are going to get 5.66, and this value is 1 ohm. Okay, so now we will need to find out RThevenin looking from the open circuited terminals. Okay, so when you see here, once again the current is entering, current is dividing. I can say whenever the current is dividing, I can say these two are connected in parallel. So between the nodes 1 and 0. Okay, so between the nodes 1 and 0, I'm going to get a single resistor where this is nothing but R Thevenin. So R Thevenin is equal to, when you do it, then you're going to get 5.66 into 1 divided by some 5.66 plus 1. Okay, so when you solve it, 5.66 divided by 6.66, you're going to get it as 0.850 ohms. So this is the value of RThevenin we have been obtained. So RThevenin is equal to 0.850 ohms. Okay, so now let us make this value and substitute in our formula. So we are going to get So just substitute in this formula of RThevenin. So then if you substitute 6.4 whole square divided by 4 into R Thevenin. So the value of R Thevenin is 0.850. Then when you do the calculation using your calculator, so therefore you are going to get 0.85, and automatically the answer is 12.047 watts. Hope you are able to understand the problem. Just go through the problem again. Just unable to get the logic. I am assuming this node as node 1 and this as node 2, and I am applied nodal analysis at 3 branches. I got the one equation. At this node again I applied the nodal analysis. I got second equation. I solved and I got only the value of Vx, but actually I require VOC. So I applied KVL inside this loop. Therefore, I got the unknown VOC value, open circuited voltage, and 4 into R Thevenin. The same procedure, voltage source is there, you short circuit it and replace it, automatically you get whatever the value. Therefore, the resultant answer you are going to get it as 12 watts. Hope you are able to understand. So if you feel the content is useful to you, please like the video, share it with your friends, and if you have any doubts, let me know in the comment section. And if you are watching the channel for the first time, subscribe to my channel for more updates, for more unsolved problems. Kindly support this type of free channels for the development of students as well as faculty. Thank you for watching patiently. Just watching this channel or watching this, you will not get anything. Just watch it and write down the given question and solve of your own, which will help you to solve more problems and where it will develop the confidence for you. So hope we'll meet in the next video. Thank you for watching.